Hello friends, today we'll start the hydrogen spectrum. When an electron jumps from the higher stationary orbit to the lower stationary orbit, a radiation of frequency nu is emitted. The frequencies of radiation which the hydrogen atom can emit are obtained by the third postulate. Energy EP of the electron in lower peak orbit is EP is equals to minus me raised to 4 upon 8 epsilon naught square p square h square. Energy En of the electron in higher nth orbit is En is equals to minus me raised to 4 upon 8 epsilon naught square n square h square. When an electron jumps from an higher orbit with energy En to lower orbit with energy EP, then the energy emitted will be h nu is equals to En minus EP. So we can write h nu is equals to minus me raised to 4 upon 8 epsilon naught square n square h square minus me raised to 4 upon 8 epsilon naught square n square h square. Okay, the value of En and value of EP, En minus EP. Solve this. H nu is equals to me raised to 4 upon 8 epsilon naught square h square common. Okay, remaining term write 1 upon p square minus 1 upon n square, 1 upon p square upon 1 upon n square. Therefore, nu is equals to me raised to 4 upon 8 epsilon naught square h cube. This is here. Okay, h cube 1 upon h square and h is h cube 1 upon p square minus 1 upon n square, 1 upon p square minus 1 upon n square. Since C is equals to nu lambda, C is equals to nu lambda. Nu is the frequency, lambda is the wavelength. Okay, lambda is wavelength and C is speed of light. We have C upon lambda. Okay, C upon lambda is equals to me raised to 4 upon 8 epsilon naught square into h cube into 1 upon p square minus 1 upon n square, or 1 upon lambda is equals to, rearrange this term, me raised to 4 upon 8 epsilon naught square into h cube into c. into C into 1 upon P square minus 1 upon N square. 1 upon P square minus 1 upon N square. Okay. Or right here 1 upon lambda is equals to R into 1 upon P square minus 1 upon N square. R into 1 upon P square minus 1 upon N square. Equation number first. Equation number first. Where R is equals to me raised to 4 upon 8 epsilon naught square h cube C is the R. So write here R and remaining term as it is. Okay. R is the Rydberg constant. R is the Rydberg constant and its value is 1.0 1.097 into 10 raised to 7. 10 raised to 7. Okay. The value of Rydberg constant. This. Okay. The wave number nu bar. The wave number nu bar of this radiation of this radiation is given by nu bar is equals to 1 upon lambda. 1 upon lambda. So right here 1 upon lambda's value nu bar is equals to R into 1 upon P square minus 1 upon N square. 1 upon N square. Okay, equation number second. Equation number second. A series of spectral lines arise on account of transitions of electrons from higher state to lower state. These spectral lines are listed in this table. Spectral lines, final states, initial state, spectral region. First is Lyman. Spectral series is Lyman. Final state 1, initial state 2, 3, 4 and spectral region is ultraviolet. Second is Balmer. Final state 2, initial state 3, 4, 5 so on. Spectral region is visible. Spectral series Fashioned. Final state 3rd and initial state 4, 5, 6 so on and spectral region is near infrared. Spectral series bracket. Final state 4, initial state 5, 6, 7, spectral region is infrared. Spectral series P1, final state 5, initial state 7, 8, 9 and spectral region is far infrared. Thank you.